Welcome everybody to our June Omaha DevOps Meetup. And this is our third virtual meeting. And as you can see, we're two in a row now for Zoom. So I think we'll continue using that instead of we use YouTube video there the first time. It didn't feel too interactive there. And I think plenty of the comments shared the same sentiment with that. So we'll continue using Zoom. And I don't know if right now we have this meeting, obviously. Next month, we've got our July meetup already set up. And Vahia, I'm saying his name wrong, I apologize. But we're going to be doing multi-stage pipelines with YAML and Azure DevOps. We've got an August meeting already set up too. Steven's going to talk about DevSecOps, so a security talk, which would be pretty exciting there. We actually we have an opening for September. So if anybody's interested in talking in September, we've got an opening there. And then October is going to be our second annual Global DevOps Bootcamp. So it's basically a worldwide hackathon. And we're going to be doing DevOps exercises. They just announced Gene Kim's going to do the keynote for it globally. And we hosted it last year, and it was a lot of fun. Basically get these exercises and break into teams, and you have to try to solve them, and you get points. And we gave prizes to the team that finished first, and then some other prizes too. So should be a lot of fun. Again, doing it again this year. It was originally supposed to be in May, but obviously COVID pushed that out. Now it's going to be October 24th, and so hopefully we'll be able to have an actual live meeting by then. Right now, the rest of them just planning on keeping them virtual until then. So we'll see how things work out. If we get a lot of people wanting in-person meeting sooner, maybe September, we can definitely look at that too. So pretty exciting. We've got some good meetings lined up though. Again, if you're interested in talking in September, let me know. We are still looking for sponsors in July, August. Meetings. So if anybody interested in that too, got a few people reached out to you on that. So waiting to hear back. But as right now, we don't have any sponsors for those. However, we do have a great sponsor tonight. So we'll get to that here in just 1 second. But yeah, just and I don't know, Andy, I didn't check with you beforehand, but with the group, I don't know if you want questions during, if you want to, or if you want people to put questions in the chat window, and then I can moderate either way.
Yeah, we don't really have a lot of people here, so feel free to interrupt me, stop me. We can talk. I might delay it for a future slide that might cover some stuff, or if you just want to put it in the Slack channel, I do have a kind of at the end we can do some Q&A too. But with I don't know, we only got 8, 9 people. There's a person I recognize getting on. This should be, yeah, I'm very much a hand wavy. I tend to probably talk too much. So please interrupt me and stop me if you got a question.
All
totally
right.
Fine.
There you go. So yeah, definitely feel free to unmute then and chime in on any questions you have during the talk, and we'll definitely have time at the end too there. So, before we get started though with that presentation, just wanted to give our sponsor, Tech Systems, a chance to kind of talk for a minute. Derek has been nice enough to sponsor us. We're going to have gift cards at the end for a raffle, so pretty excited to have that. So Derek, I'll kind of turn it over to you and let you kind of talk about Tech Systems.
Awesome, man. I appreciate it. Good afternoon, everybody. Mike, I appreciate you setting this up, and Andy for speaking with us today. Second of all, I hope everybody is staying safe and healthy with everything currently going on in the market. Don't want to take too much of your guys' time here. Want to get going, but wanted to give you guys a formal introduction to myself. My name is Derek Formanak. I'm kind of our DevOps and cloud-focused infrastructure recruiter here at Tech Systems. I do see a couple of familiar faces and names here online. So a couple of you guys may be familiar with tech, but wanted to give a broad overview quickly. So Tech Systems itself is an IT services company that focuses on application development, infrastructure, and dynamic workplace services. In the past, we've kind of been branded more as that staffing firm, and that being honest, that has kind of been our bread and butter over the years. But in the last 5 to 10 years, our upper management has really made a switch and has focused to more of a outcome-based solutions type company. So within that, we obviously have 4 different types of delivery. The first one being staff augmentation, second, co-managed services, thirdly, project-based services. And then we also have started doing fully outsourced services with a couple both onshore and offshore delivery centers. Onshore, we have one here in Dallas. And then as far as offshore, we have 2 different centers, one in Bangalore and one in Hyderabad. We also have different channel partnerships that we like to leverage, specifically relevant to this DevOps talk. We have partnerships with AWS, Google, GCP, and obviously Microsoft Azure. When it comes to DevOps, for me particularly, as a company right now, we have 297 DevOps engineers currently consulting for us. A little over a dozen of those which are local to the Lincoln and Omaha markets here. So I appreciate you guys taking the time. If you have any questions or concerns or ever need a resource within the Omaha market, I'd love to network and or talk to you guys and kind of let you know what different things we're seeing as time continues with COVID and everything throughout the market. So like I said, any questions or concerns, feel free to email me after. And with that, I'll let Andy and Mike kind of take over here and get going.
All right. Thanks a lot, Derek, and thanks a lot for your tech system support of our group. So we'll catch up with you here at the end here for the drawing. So thanks, Ian. And we're going to get to the presentation then. So Andy Ochsner is talking about improving the developer experience with 3 Musketeers. So topic I'm really excited to hear about. And I'm going to go ahead and turn it over to Andy then and let him take on. Thanks, Andy.
Can you guys see my screen all right?
Yep.
All right, cool. Fabulous. Right, so let's talk about improving the developer experience with 3 Musketeers. I kind of after hearing this, realized, well, this isn't just developers. This could apply to infrastructure engineers, operations, but I mean, in a DevOps world, we're all developers in the end. So let's start with the story. We'd like to welcome our newest developer, Maxine Chambers, to the Unicorn Project at Parts Unlimited. If you're familiar with this book, I am lifting and sort of morphing some of this, but it just really resonated with me when I started reading it. Right, so Maxine, before she starts, her accounts get created, she gets her default entitlements. Hopefully her manager remembers to add her to the groups that he remembers that she'll need. And the day before she shows up, he finds a senior engineer to notify him that she's joining and that you're he or she's your buddy. Of course, the senior engineer is already overbooked, so good luck trying to find some time. Day 1, hey, you go, you do your onboarding, you meet your manager and your buddy, and they introduce you to the rest of the team. They walk you through kind of an overview of the application. It's really cool. It's a modern microservices architecture that leverages, quote, the cloud, and it uses Kubernetes. So modern stuff, where this isn't brownfield stuff. They're leveraging Docker heavily because they've kind of bought into the value of kind of that portability and sort of common platform. You're ready to have lunch? Great, your credentials are ready. Your first task is to build the application locally. And because everybody's a little overbooked, they give you a link to a Confluence and a link to GitHub. And oh, by the way, if you could update any out-of-date documentation, that'd be really helpful for the next person, because it's just kind of what we're going to have you do. And so you open up Confluence, and Maxine opens up Confluence and notices it hasn't been updated in over a year. So she's already feeling really sad, but she gets to reading, right? So her days continue. Step 1, okay, she looks at GitHub and notices, walking through the Confluence side, if you downloaded JDK, it says version 8, you go get version 8, download Gradle because they're not using the Gradle wrapper, install Postgres, happen to mention version, kind of luckily point you to some scripts that you can use to get a development database. It doesn't get a development, it really just copies another development database kind of locally, and you go to the GitHub repo, you clone it. The README is empty because no one really bothered to write a README. That's very helpful because this is all internal. So you're just going to go off the Confluence page. So your next step is to build it. Okay, cool. Gradle. Gradle is great. We're going to do a Gradle build. The build fails. Unfortunately, we come to find out that you're kind of leveraging some APIs from a newer JDK. You talk to your senior engineer. Oh yeah, we upgraded that a few months ago. We forgot to update the onboarding documentation. If you could do that, that'd be great. So okay, rinse, repeat, download JDK version 11, run your Gradle build. Now you get, the build's failing because of an authentication error. The password's blank because they're good. They're not putting passwords in source control. So, okay, you got to go ask a teammate, go find out what the passwords are, rinse and repeat. You kind of go through this process in day 1, day 2, day 3. It's all these little things that add up. You don't have access to the right shoulder, shared folder. So you're waiting on a lot of it, and the Unicorn project touches on this there's a lot of waiting in a lot of cases. You're waiting for answers from other people. You're waiting for permissions from other teams. You're waiting for approvals. You're waiting to get an email back. Maybe fortunately, if you were working in Slack, you get a little bit more responsiveness. I'm on a client that didn't have Slack at the beginning. Fortunately, we got it right before this COVID bit, and I was talking to my colleague, and we were just talking about wow, that's made things really easier. Nothing beats face-to-face kind of communication, but this is kind of the normal experience. And a lot of times people forget all this onboarding pain that people go through, and usually it's brunted by the new person that probably doesn't have any idea if they're doing something wrong on their machine, or if the documentation hasn't been up to date. Maybe by day 4, hey, cool, it builds locally. So you make your first commit on your new feature, your build passes locally. You want to run it, so you run Gradle boot run. Huzzah, it works. You push it to the feature branch, but the Jenkins build fails now. Because in Jenkins now there's some additional analysis. You're doing SonarQube analysis that failed. So that's not actually executed by Gradle. It's executed in your Jenkins file. It's kind of a one-off little thing. So now you've got a situation where, okay, I've got things that only run in my Jenkins. So I try to address the issues. I commit, I push, I wait for that build to fail. So now I'm in a longer cycle of commit, push, let a Jenkins build go, rinse and repeat. So now my cycles are going a little bit longer. Finally, the Jenkins build passes, but now maybe your deployment build fails because now the application is deployed as a Docker container with the Helm chart. It's not executed in a via Gradle boot run or anything like that. So while Gradle's great, it certainly is a step up from Ivy days, Maven days. And I'll admit this is a bit Java centric, but you could say the same. You've got the same thing for Go. It's got its own command line utilities, NPM, even .NET. Python actually kind of sort of doesn't, although I'm not super familiar with Python. But a lot of places I've been, you're manually running Python scripts or running Bash scripts that execute and sort of orchestrate your build. So that's great. The problem is it can't do all of these things, and it's not executed the same way in your Jenkins build. And Gradle depends on a lot of it has a lot of assumptions baked in that you're on the right version of JVM. That if you've got any other dependencies, like if you're not using the Gradle wrapper or anything like that, you have a number of steps. So it goes on. It goes. And that's kind of the onboarding experience of a lot of people. I know this firsthand because let me tell you a little bit about myself. I'm a technical principal at a company called Contino. We're a consulting company. Things that really spark joy in me is lean and agile delivery. I've been doing lean and agile and extreme programming kind of my whole career of almost 20 years. I was doing DevOps stuff before it was called DevOps. I'm sure many people here were. I've gotten into the worlds of software architecture and software development. I've come to DevOps more from a dev perspective, sort of trying to hack my way around ops and then really kind of appreciating what happens. And I work with a lot of colleagues that have kind of come from the other side, and I really kind of get to see the rigor and the focus on removing toil that I'm like, man, I wish I worked with wish I worked with operations people like you, because this is awesome. So I've really enjoyed kind of being where I'm at and getting to kind of see both sides, and really seeing that cross-functionalness. And a lot of times that comes down into CI/CD, a lot of build pipelines. We do a lot of pipelining is what I tend to talk most about when doing DevOps. And I also like test-driven development and behavior-driven development. Contino itself, I won't spend too much. There's enough branding going on here, but we've got it. We're growing kind of DevOps, digital transformation consultancy. So we're not just doing DevOps. We tend to focus on large enterprises that have a lot of regulations. Really do focus on transformation, and a lot of that ends up being more about people and process than it does technology. So a lot of our engagements, we've worked with kind of a number of global offices. We're still a decently small company, and 360 plus people, but we're trying to grow really rapidly. We did get acquired by Cognizant within the last year, so we've got a lot of backing, but we're still pretty independent and get to stay pretty nimble. So we've had a lot of experience being around different organizations. All of them have similar challenges, just kind of in unique ways, but it usually all comes down to people process before kind of enabling technology. That's a bit about Contino. So what are we going to do today? So I wanted to talk about Three Musketeers and how it can kind of solve the problems I talked about. It's got a bit, I kind of realized it's got a bit of a software engineering focus, because that's sort of what I'm working on with my client, where I come from. But it's really a pattern that's picked up a lot of steam. I learned about it within Contino. A lot of people were using Terraform and building out AWS landing zones using Three Musketeers. So it's really, what I want you to get out of it is it's a pattern. So we'll talk about who they are, what they are. Here's a hint that will be picked up in the next section around calling about Docker, Compose, and Make. Hopefully go through a few demos, talk through kind of my lessons learned and gotchas, talk through some of the trade-offs and the alternatives, because the reality is this isn't going to solve everything. I'm coming from an architecture background, like there's no silver bullets. It's all when you're making design decisions or technology choices, it's all about trade-offs. It's true of process that you're going to use, et cetera. So I really want to help you understand what the trade-offs are, that this isn't going to solve world hunger for you, and that there are some drawbacks and there are alternatives. And if you have this as another tool in your toolbox and see what it solves, maybe we can kind of keep moving things forward. Hopefully that sounds good. And then Q&A discussion, just whatever. I've got a whole slew of slides where I can really dive in deeper. I didn't know how long I'd talk, but I tend to talk too much and don't leave enough time at the end. But like I said, interrupt me if you want. So the Three Musketeers, they are Docker, Docker Compose, and Make. Yes, I said Make. I had the same reaction, which was Make, really? So hopefully people are familiar with these tools. I think most people in a DevOps space are. So Docker, what does Docker do? Docker's leverage. So Docker provides, sort of platform isolation. It gives you, a lot of people are moving to Docker to say, hey, I want to have more control and more standardization from an operations perspective, so everything kind of looks the same, as well as from a development perspective of saying, okay, I want to be in control of when I upgrade from Java 8 to Java 11, that I'm controlling that I don't have this dependency on a separate platform team that has to run an upgrade. And again, it gets you treating servers as cattle instead of pets, right? These aren't your little pets that you're going to nurture and keep alive and patch over. You'd love to just sort of have them be ephemeral and idempotent, and when you need to upgrade, you just recreate a new container and ship it and kind of have it be a one-way thing. It's nice that it provides some. Where we use it, and what I'm talking about using it, is in your local development platform. So a lot of times we use it sort of after the pipeline. What we're building is a Docker image, but when we're building things locally, I tend to kind of skip that step. I'm working in my IDE. I might not have Docker. Maybe they don't allow Docker or Docker Compose on my local virtual desktops, that's a challenge we've had to face. So, you know, if you're facing that, you probably can't use this, but we can talk around alternatives that might work for you. But Docker's really an important one. I'll go into a little bit more details on some of these. Compose, Docker Compose, sometimes just called Compose, is really good at orchestrating multiple Docker containers. That's true. So if you've got an application that depends on a database, that's a really common example. What a lot of teams, what I've done in the past is, you know, maybe I'm running my unit tests against an in-memory database, but really my target database is a Postgres database. So I've got to deal with unique nuances of SQL things that maybe I want to leverage that the in-memory database doesn't. Again, over time, these things sort of level out, but there are differences. But then, even then, you know, maybe I'll have a locally installed version of Postgres. That's great, but again, you know, people tend to not pay attention to versions, and it's not standard if I'm running things in a Windows environment or Linux environment or Mac environment. So Docker kind of gives you that standardization. Compose helps by sort of creating a network so that these different independent containers can kind of talk to each other. The other way we leverage it in Three Musketeers is to simplify a lot of the makefile and the Docker commands. I'll kind of point through a little bit of that. So keep in mind, we're not really leveraging Docker and Docker Compose in this case to handle deployments, or we aren't going to use it as kind of our mechanism of deploying our applications. We might use something else like Kubernetes or Helm or kind of any other, pick a platform as a service tool from any of the cloud providers. It's again really just kind of help local development and simplify those makefiles. Make, hopefully most people know what make is. It's been around longer than I have, maybe even been around longer than other people here. I'm probably older than many here, but yeah, so it's been around. It's an oldie but goodie. It's nice because, so the reason it kind of gets leveraged is it's nice because it is multi-platform. So there are make tools on the Windows tool chain, on the Windows OS. It generally comes out of the box on a Windows or on a Mac or a Linux system. So it's really kind of nice. I've tended to work a little bit more in Mac and Linux, so I tend to get in that frame of mind. Although I'll say, like, writing cross-platform make files can be really, really, really challenging unless you have a Windows system and a Mac or a Linux system. So while that's one reason why we like to keep our make files really, really simple and not do too much, you know, kind of any sort of OS specific stuff. Do it within a Docker container so you get that standardization. But really, it's just a build orchestration tool, if you will. If you've used you know, if you've used npm, if you've used Gradle or Maven or you know, even Ant or NANT or any of the other .NET spaces of tools in the .NET tool chain. It's just another one, right? You've got build targets. You can do stuff within those build targets. You can have dependencies. It's a little terse, and it's got its little gotchas in there, like you know, tabs over spaces. So you know, you don't have to have that argument. You have to use tabs. Don't use spaces. Anyways, hopefully that makes sense. Hopefully people are familiar with it. Why is this good for you? And this is probably the biggest thing I want you to get out of this. So this is a pattern, and this is really why it's valuable. It's three things. It's consistency, control, and confidence. So consistency, we want to make sure we run the same commands no matter where we're at. So like I said, writing cross-platform make files can be really challenging because you can bake in a lot of assumptions that you're on. It's really easy to make things and see it works on your machine, but when a teammate who might be on a Windows machine tries it and it fails, or if you pull out, you know, if you find a really cool open source software tool and you're like, man, I really want to use that, or I really want to tweak it and build it for mine, but I'm on a Windows system, and trying to just get that thing to build on my Windows machine when everybody else uses Linux or Macs, it's a really painful experience. So what we're really looking to bring is consistency. Again, there's always going to be those differences, but if we treat Docker as kind of that baseline where everything's going to kind of run through there, we get that consistency. So I can start to bake in assumptions that I'm on an Alpine Linux or, you know, a Linux system. There's even, you know, even if your target is a Windows system, there are Windows Docker images. So a lot of good stuff there. Plus the advantage is a lot of CI/CD tools are kind of supporting Docker more and more. Jenkins does, Travis, Circle CI, GitLab CI, a lot of the newer ones. That's kind of the base entry of, hey, you know, rather than kind of, if you've ever had to maintain a build agent in Jenkins and do so manually, and it's a pain, right? Because especially if it's a centralized Jenkins suite, because everybody has their own tool set and build tool chain. Oh, I need Jenkins, or I need a JDK 8, I need Python 3, I need Python 2, I need C++ build tool chain, I need NPM, I need, you know, I need this plugin, I need that plugin. That ends up being really, really hard to maintain over a long period of time. By leveraging Docker and leveraging kind of this approach, you get first day productivity. So I'm going to show you how and why that is, just kind of limiting the number of prerequisites. You know, you just really only need to support one build agent ever, right? Something that can run Docker is really all you need. Really would encourage teams to move away from a lot of the plugins in Jenkins or a lot of these other tools, because it really, it ties you to that build tool or to that tool chain, that CI server. That's crummy, but I don't see companies changing that very often, so whatever. But it does make it harder to recreate, you know, that build locally, and that's what we're really trying to do. So if I'm dependent on Groovy scripts or a set of plugins on a Jenkins server, it makes it really hard. It lengthens those feedback cycles to kind of move quickly. One of my colleagues did some ROI calculations and said it was about a $4,000 to $7,000 savings per new joiner. So if you calculate kind of what their day rate is, and if it takes them 4 to 5 days to be productive just to get that first commit working, I mean, that's real tangible money. And the reality is a lot of companies I work with are large enterprises. They outsource a lot of teams. They have a lot of turnover. And so if you're doing this frequently, I mean, it compounds over time. So that's in the consistency space. In the control space, you know, kind of getting back to developers and engineers in general want control of the languages, the versions they're using, the tools they need. And the nice thing about using Docker and Docker images and kind of this approach is that you kind of get more control over that. I'm not dependent on a platform team to upgrade build toolchain versions or upgrade a Jenkins plugin version or install a new plugin version. I now have more control, and yeah, that adds to more governance. Maybe you have to approve, you know, you don't want everybody using every popular development tool in the world. Like maybe not everyone's going to become Rust experts, but you can control that through Artifactory policies, through you know, having an artifact repository, those sorts of things. So again, you want to try to get to a point where your pipelines are just dumb pipelines. They're just executing things, and the smartness is really in your build scripts that you have control over. You want the platform team to become an enabler, not just this version police, and you don't need a bloated CI or CD tool with 3,000 integrations and plugins, and it only works in that tool, and you'll never be able to extricate yourself from that, and it makes it really hard to test. Finally, you want competence. You want to be able to test your code, test your pipelines locally before you check it in. Yeah, these CI tools are really good at running your builds on your branch, so you're not breaking things and checking things into trunk all the time, but it lengthens that feedback cycle. Again, it reduces, you know, no more is there going to be, you know, trying to figure out, hey, these tests run on my machine, but they're not working on the build agent. What's wrong? And you start to figure out, you know, it lowers that blast radius of, okay, what could possibly be wrong? Did I forget to check something in? At least I know, you know, if my Jenkins build is running, if my CI tool is running a different set of scripts that I'm not running locally, okay, now I have to go back and see if something changed. Does that change the order of the tests that run? And I had some stupid assumption that they'd run in a particular order. Bad on me, but these are things that I've seen happen. It also, you can really expand that. If I can make it consistent to where I can spin up an entire kind of local ecosystem, I can run full web UX complex database integration tests all within containers, all within my local machine. And so, you know, then if I change my tools, it's not much of a problem. It's a lot more portable. Any questions, concerns there? I spent a lot of time. This is what I'd love you to come away with around what it is we're trying to solve. All right, so let's take a little bit of time and kind of diving into each one. Docker. Like I talked about, Docker is the most important of the three musketeers. That's probably the entry stakes, probably the one you want the most. Again, the whole point of it is, you know, you want to be, you're using it as kind of a task execution engine, right? You're using it to run, to build and test and run and deploy all inside lightweight Docker containers. The port of it, you know, Docker ends up, the advantage and why we use it in, you know, kind of our CD areas as the same on our locals, is that it gives you that portability so that you can execute kind of the same tasks in the same way on different environments and with different CI/CD tools. So it's really just an abstraction layer and give you control of your build tool chain. So just simple example, you know, if you want to run a hello world, this is what it looks like, right? Docker, run, remove. Okay, I'm going to run an Alpine. I know it comes with an echo command. Cool. Now we've got not a ton of value here, but hang with me. Docker Compose. So I talked about Docker Compose or Simply Compose. So it manages Docker containers in a pretty neat way. So if you've, I can't really see people to raise their hands if they've used it a lot. I tend to use it a lot in the past, kind of before I got the Three Musketeers, was, okay, I need to, you know, I want to do some integration testing. I've got these 5 different components that kind of need to talk to each other. One's a database, maybe some APIs in there, some microservices, and a UI front end. Before I try to, you know, spin those all up locally, that kind of gets to be, you can make it work, but, you know, when I came across Docker Compose, it's like, oh, cool, Docker Compose up. I've got this whole environment that has a network that can all talk to each other, and it exposes some ports that I can access locally. That's awesome. I want to do more of that. So that's really what it's really nice for, and what its bread and butter is. The other advantage, and the thing we tend to focus on a bit more in Three Musketeers, is that it simplifies kind of those Docker command calls. If you start looking and adding more complexity, doing port mapping, volume mapping, environment variables, you know, kind of those are kind of the top areas. You start getting a lot of esoteric command line arguments into the Docker run command. You've got Docker run and Docker build, and there's all these different commands. It can get really confusing, really messy. And so Docker Compose is really nice because it does really simplify some of that. And I'll kind of show you what that looks like in a little bit. And then finally, I kind of skipped ahead. So it makes it a little easier to kind of isolate some of your testing. Oh, you need a Postgres database? Cool, we can get that spun up pretty quickly using Docker Compose and maybe the image you built, and they can kind of talk together, and it manages that pretty nicely. So what does Docker Compose look like? So again, you're gonna look at this and say like, wow, it looks like we added complexity, and that's true. This, I generally wouldn't, if I'm doing hello world, I wouldn't bring in Docker Compose because the Docker command was pretty darn easy. But this is what it looks like. You know, Docker Compose is really defined as a YAML file. So it's just kind of putting a little bit more words around stuff, and you can kind of declare your dependencies and that sort of thing. So again, bear with me. I know this is a contrived example. Make is a cross-platform build tool. You've probably heard of it. If you've ever built anything in C and C++ back in the days, you've been exposed to it. Originally created in 1976, which was 3 years after I was born, so it's older than me. Which is amazing. So look, I'm going to talk through a few gotchas. Will be like Docker and Docker Compose has some bugs, and it's still relatively new and emerging technology generally. There are some gotchas about making sure you're using the right version of Docker and Docker Compose, which isn't unlike, the same issues we had with the JDK back in the example. You rarely have to worry about what version of Make you're using, because that's been pretty solid and hasn't changed all that much, at least the bulk of it, for many, many years. Again, and I'll touch on this, there's other tools. You don't have to use Make. The reasons it's chosen here is because it's generally widely available, cross-platform, doesn't really have any other dependencies, especially in Linux and Mac systems. It's just there. But you can use tools like Rake or Ant or NPM to kind of achieve the same goals. You just need to have Ruby installed or Java installed or Node installed, and it's just yet another dependency. That's kind of why Make was chosen. So an example, you've probably been exposed to this. If you've looked at a complex one, it's really terse. So hopefully I've gotten you to the point that we don't want like really terse things, although as you learn more about Make and its nuances, you naturally fall in there. Here's what a Make file looks like. So this is the command echo, and this is, again, there's a tab in between here. My echo, because I said echo, is going to want to say, what did you want? And then it's just going to execute statements. So you can have multiple statements underneath here. It'll run Docker Compose. Maybe you need to run a couple other things. So that's just kind of the quick and easy format. You run make echo, and it'll run Docker Compose, and it'll echo things out. So really complex, contrived, simple example. Questions on that? Reactions before I dive into some demos?
I think it's interesting how Make uses tabs and YAML uses spaces. So gotta keep that straight for everybody.
Yeah, make sure your editor.
Straightforward.
Yeah, make sure your editor knows the two. I had to install a Makefile plugin for VS Code, which I'm going to be working in, because that really helps, or like an editor config.
Andy, you made me feel old. I think I might be one of the only ones here that is actually older than Makefile.
I was worried that you were on the cusp. I knew you were somewhere like really close.
I don't feel older than it though.
Good, young at heart. Cool. All right, so hopefully you at least understand the motivation. We'll go through a few examples here. The examples I've got are I've got links to all these at the end, and I'll shoot out this. I'll probably even post it in this GitHub repository. So we've just got some simple examples you can go out and check out. There's a couple other resources kind of at the end that I'll point you to. So let's have a look, right? So in our Hello World example, I'm gonna delete this file really quick. This is a bit more complex than sort of the contrived one that I was talking about. That's not what I want. Let's talk. Well, here, let me go into my Hello World example. So this is really going to touch on using the three Musketeers. I am going to use Make and Docker Compose. I'm going to introduce environment variables and how those kind of play a role, because if you're kind of following modern 12-factor app sort of steps, right? One of the key ones is that your configuration comes through the environment, through environment variables. So you tend to see in a lot of, especially cloud native, Dockerized solutions, that they really depend on this, right? You don't want to have to rebuild a Docker image every time you need to change a configuration file. You want it to be a little more dynamic than that. You want to be able to take that image, run it in a container in dev, have that dev environment sort of configure that, and it can run there. You take that same binary, that same image, and promote it to test, all without kind of recompiling. So it's a build once and promote system if you really want to get to kind of a true CI, continuous delivery cadence. So environment variables play a big role in that. I'm just going to kind of talk through, and that's kind of one of the areas and gotchas that can be a little bit confusing. So similar setup, more complex Makefile. If we kind of walk through it, this kind of follows a lot of the patterns, and I've got some links to kind of some common Three Musketeers makefile patterns, but I kind of baked it all in here. So this is a little bit more complex than sort of what we went through. So I'll try to explain some of it. There's kind of generally at the top, you're going to declare your variables. Make has their own variables, and by default, it'll convert all of the environment variables when you run make, and convert them into make variables. So that's kind of one little gotcha, that make is going to look and feel a lot like a shell, that I can run commands and I can export variables as if they're environment variables, and I can run the next command and it'll pick it up. That's not the case. Every single task and sort of target recipe step. So if I want, maybe I want to do a make show help or something like that. Each one of these steps are going to run in their own shell. There are some ways to override that, but it's not a shell, so you can't like export environment variables within make like you could if you're in Bash or PowerShell or anything like that. So that's one thing to know. So typically you'll find kind of the commands of running Docker and running Compose will generally be towards the top, because there's all these command toggle, command line arguments and options that get passed around. And that can really kind of clutter up your make file. So generally you'll see that at the top. We're going to declare an environment variable. There's different ways to set environment variables. It's not really obvious. This one is actually lazy loaded. Generally, we don't do that. I think I forgot to kind of catch this, but that means every time this variable is referenced, it's going to evaluate the thing on the right. If you want it to only evaluate once, you put a colon in front of it. Again, I'm not going to try to get too far in the weeds of make, because that would take up another hour, but there's little nuances. The question mark means if it's not already set, defaulted, so you can kind of override those defaults. At the top, you'll usually see kind of an all. By default, make is going to, by default, well, if you just run make with no arguments, it's going to run the first command that it sees. A lot of times you'll either see that be a help or kind of an all command. This is kind of a pipeline command. So these are sort of all of the steps that it takes to run from start to finish. So it's going to run make end file, followed by the echo, followed by cleaning up. So if you kind of dump through here, so an end file, we've got, let me sort of drop down to what the thing is that we're actually doing is we're just going to echo out a variable called echo message. It's all we're trying to do in here. And so we can pass in environment variables in a number of different ways. Typically you'll find in a .env.template file. This is nice because it sort of declaratively tells you, okay, these are all the environment variables that are used to configure this. So it's really kind of self-documenting. The other advantage is if you're familiar with Docker Compose, it can take advantage of environment files, typically .env files. And if you just leave it blank like this, what that means is it'll automatically pass in that environment variable if it exists on the host that's running the Docker command and pass it into the container. So you kind of get this automatic flow of environment variables. You'll also generally see an example of like, okay, what does this environment variable look like? What's its common options? And so you'll see a .env.example. And so what we do to take advantage of that is if you're running all, it's just going to automatically use this .env example and call make env file. Make env file, all it's doing is it's going to clone that end file. So if you pass in and say, hey, this is the end file I want to use, if you don't and you default it, it's the .env.template, and it's just going to copy it to .env. So if I run like env file equals .env.example, and then run make env file. Oops, sorry, I need to go into the first one. env file .env example make env file. Sorry, I forgot I wasn't running Docker. This is what I get for running through this right before. Similarly, while I'm waiting for Docker to come up, you'll probably see this .phony. If you've come around a Makefile, you've probably seen .phony and had no idea what it is. I had no idea what it is until I started using Three Musketeers a bit more to remind myself. As a default, Make typically thinks of your targets, this like in file all, as a signal that you're intending to write to a file or a folder on the file system called env file. And so what it generally does is it looks to see if that file or folder exists, and if it does, it skips running anything in there. If it doesn't, it's going to go ahead and run it. Generally, you probably don't need .phony. Where it does catch you is in cases if you're like running, if you've got a build command that's build, or if you've got a make command that's build or test, and you have a build or a test folder, then things get wonky. So generally, since we're really just only using make to be a build sort of orchestration tool, you'll generally just by default, it's better just to put .phony in there. So that it'll always run it and treats it kind of like as a phony target is what it's intended for. Okay, Docker should be up now, so I should be able to run this. Right, cool. So now I've got this .env file copied from my env example. This is what my echo message is. Cool. So now I should be able to run echo. Okay, cool. So another example, another pattern you're going to see is kind of this target and an underscore target. The difference is the target, these are kind of your publicly facing things that people would execute, and the underscore one are kind of your private ones that actually get executed within the container. So here we're going to run a Three Musketeers container using Docker Compose, and we're just going to call make sort of within that container, calling this echo command down here. Why do we separate this? So it's kind of a performance enhancement, if you will. If I already have make installed, as opposed to if I'm on a well, I'm using Three Musketeers here, so that's maybe a bad example. But if I'm in the next one, I'll show you an example. If I've got all of the dependencies that the Docker file, that the Docker image has, I can just call that private one directly. I don't even have to go through Docker and deal with that overhead. But it does sort of condense things down and kind of gives you one place that says, okay, this is how I'm going to execute it. If I look at my Docker Compose, so again, this is just making it a little bit easier to execute. So I'm using this image. This is just a Three Musketeers image. It comes with Docker Compose, Make, and Docker, I think. I can tell it a .env file. So this is going to pick up that env file and put it it'll be in the environment of the running container. I'm going to attach a volume. So I'm going to basically take this source code that I have and attach it to a volume, and that's going to be my working directory, which is really important because I really need that make file inside the container running, because I'm going to recursively call it. I'm going to call that private one inside the container. So it's kind of this public private. This is what I'm doing outside of Docker, and this is what I'm doing inside of Docker, or inside of an environment that has all of the dependencies and tools and things that I need already set up for me. Does that make sense? So if I run make echo, I should see it spit out hello world. Hey, cool. So it spits out hello world. Really, really awesome. If I want to kind of show the other example of env file equals .env.template, make env file. So here I'm using the template instead. So now my env file is just blank, right? It's not equaling anything. So if I just run make run, make echo. I haven't set anything. I haven't set echo message, so nothing's set inside the container. If I set echo message is hello Omaha. hopefully that then flows through hello Omaha. So that's generally how you're going to flow environment variables through. So hopefully that makes sense. Any questions on that? Comments, concerns? Cool. That's really it. Generally you'll find, kind of a lot of standard, if you're dealing with environment variables, you're going to find, some sort of setting up of that .env file, some kind of run command, some kind of build command. You might even find a shell command. So if things aren't quite working and you need to sort of poke around inside the container, you'll generally have like a shell command that'll just give you a prompt, an interactive terminal inside the container, so you can kind of see what the environment is, run separate commands inside of it. And you'll usually see a clean command. So you want to clean up after yourselves. If you ever worked in Docker, especially if you're running on shared build agents, if you don't clean up the Docker images that you're building and the containers that are running, those generally don't get cleaned up automatically by a git clean or by a clean a workspace, because those live over in Docker world. It's really important to make sure you clean up after yourself. And that's, again, another area where Docker Compose is a little bit nicer, because it'll tear everything down, as well as remove any sort of orphan containers that might have been spun up that aren't needed. So all kind of typical patterns. Okay. Hopefully that makes some sense. I haven't totally bored you. I can't see people because I'm sharing, so it's the one downside to doing remote. Cool. More complex example. Again, I come more from a dev background, so I just kind of, and I'm kind of working with teams that are app dev teams, so I kind of come from that side. I'm working with some teams that are Python based, NPM based, Java based, using Gradle. I've gotten a lot of, not pushback, but a lot of misunderstanding of like, oh, Make's going to totally replace Gradle. Now I've got all this rework. This is stupid. And I'm like, yeah, if that were the case, that would be stupid. That's not what I'm trying to say. Or I see people that kind of conflate things like, oh, this doesn't work in my mono repo that I've set up. And it's really independent of all of that. You can use, I've seen this used across all sorts of build tool chains for application development teams. I've seen it used to sort of drive CloudFormation templates directly. So kind of creating a Docker container, using an AWS CLI Docker container to kind of standardize that. I've seen it used for Terraform. Again, all of these dependencies that you need to do your work can really be sort of standardized and given some consistency by leveraging Docker. Now, the reason I chose Java in particular, which is kind of an application development environment, is, a lot of the pushback I get is, a lot of my IDEs and my tools and whatnot don't use this, right? You're kind of creating two separate systems where I still need all this build toolchain stuff. If I'm going to be writing stuff in an IDE, I still need the JDK, right? I still need, maybe I'm going to use the Gradle wrapper, but IntelliJ is going to need a JDK. So are you really buying something? I can't answer that question for you necessarily. So that nirvana when you're on an app dev side is you're sort of going to lose the argument a little bit if you work in an IDE that kind of needs that tool chain already. Hopefully, I see more and more development teams, if you've got NVM to kind of control your NPM version. Same with virtual env in Python, there's a JEnv to kind of control your versions of build tool chains. My point is try to be as self-sufficient as possible, but we don't have to throw the baby out with the bathwater if we move to this. And so this is kind of the example I've got. I've got a basic Spring Boot application that just runs a very simple hello world endpoint. Ooh, hey, don't want that. I'm contriving it here by what it's going to return is hello, and then whatever the name of an environment variable is. Probably not useful, but you'll see kind of the same pattern of how environment variables get passed. I didn't get complex enough. Typically, environment variables for applications are going to be things like database connections that change across different environments, potentially secrets if you're managing it that way, or endpoints to HashiCorp Vault or any of the cloud vault and key services, that sort of thing. So still value in passing it through. Excuse me. Right, so basic stuff. This was already a Gradle application. I took it down and I basically made it into 3 Musketeers. So you're gonna see a lot of the same patterns, a little bit more complexity, because my output is gonna be a Docker image, because that's what I'm deploying into a Kubernetes world. Again, you're gonna see a lot of the same common things, right? Kind of an Uber pipeline thing that, I've seen some teams where, this all is what would get executed within the CI build. That's really cool. I tend to break them up because I like seeing separate stages at least. And I use Jenkins a lot in the companies that I work with because that's what they pick. But I like kind of seeing the separate stages. So I generally don't use that. But it at least gives you hey, all I have to do is have make Docker compose installed, despite whatever build tool I'm working. If I'm using Python or NPM or Terraform, just download it, run make build, and I've got a system where I can at least build. And maybe if all I'm doing is like changing a typo, I don't even have to pull up an IDE and all this heavy build tool chain stuff. It just gives you that consistency. So again, we're going to kind of see this leveraging this public and private target sort of thing. So the public targets, again, what common targets you'll see are test and build and run and shell and clean. I even have, so I'm, going to run those commands that are just going to basically do the standard things you do in Gradle, and then maybe have a separate set of commands to build Docker images and run as Docker images. Because I might run things under Gradle and things work, but when I go to run it as a Docker container, which is really how my application is going to get run, things are different. I like to be able to execute that locally. But you'll see really each of these private targets, they're just leveraging Gradle, right? They're just handing off to that build tool chain. So I've got an extra layer of indirection. Can't solve any, no software development, computer science problem can be solved without, every problem can be solved by adding an extra layer of indirection. So here you go. So I'm just leveraging that, but the difference is the Docker. I'm leveraging Docker Compose to give me that standardized version of which JDK I want, which base image I want to use to be able to execute these commands on. Like I said, if I've already got that installed, which I do, let me go to O2 in here, I can run make_test locally, and that's just going to run Gradle wrapper locally because I have all the stuff running. So I can kind of skip all of that if I want to, or I can run make test, and that'll run the same thing. Sorry, I have to run make and file make test. Right, so this is going to run it now through a Docker container locally. Now the nice thing, let me bring up the Docker Compose, right? So this is what my image looks like. This is the environment file. I'll do some port mapping. The volume mounts is really nice, right? So I'm, if my IDE is, or if I've built it outside of Docker, either via my IDE or via, my local make or using Gradle directly, a lot of these build tool chains will cache, dependencies or build output within your local directory. And by mounting that file system, you get to take advantage of that. So you can start to leverage build caching. Same if you're doing, your Docker build caching to make this a quicker experience. You're not like constantly downloading the internet to get all your NPM dependencies. Similarly, so Gradle stores its build caches and build dependencies in a home directory. So I can mount that. So I'm not re-downloading the Gradle wrapper every time. I'm not re-downloading all of my Gradle dependencies every time. So that, I've had teams that maybe have implemented it not optimally, and they complain. All we're doing is we're now like increasing build times or increasing times. You can solve that problem. So yeah, again, you can run make Docker build. That'll build my Docker image. If you want to look at my Docker file, this is a bit more slimmed down. The difference between the Docker image that gets built and the one that I'm leveraging in Docker Compose is because I'm using these public-private targets, I need an image that also comes with make. But I don't want to necessarily deploy an image that comes with make, because I like to keep it a little bit thinner. So maybe I'm doing my build using that same CentOS that has make, and I'm running that private build inside my Docker build. But if I can kind of leverage intermediate stages, I can kind of tighten up that final image. Once that's done, then I can show you I can run. If I run, hopefully this is making sense. If I run Omaha, make Docker run, it's going to run it as a as the Docker image, so basically as a Docker run. So now I can hopefully go out, hit localhost 8080, and it comes back and says hello Omaha. So yay. I didn't get a time to pull up an example of like having a dependent database, but I think hopefully by this you kind of get the point, or just kind of what you can do. Again, the fact that it's Java and Gradle doesn't really matter. It's really just kind of a layer that sits on top that gives you that control over your build tool chain, your versions of those tools, gives you consistency across your local development environment and your Jenkins builds, so on and so forth. I thought it's pretty powerful. Makes sense? Questions? I've got a few lessons learned, gotcha. And of course, haven't left a ton of time on my 1 hour allotment, but we do have about 25 minutes or so left. So lessons learned, things that I've gotten out of it, right? Make's a powerful tool that can do a lot of things. You can get really, it's a really dense and terse language. And I catch myself taking advantage of that because I get really curious around, ooh, what's this dash that happens beforehand, or what's this, colon equals versus question equals versus, I even think there's one other one that I don't use very often. I'd say, try to avoid it. Try to keep things as simple as possible. Honestly, it makes new people who are new to Make, it makes it a lot easier for them to onboard and be able to make changes. That said, I would try to learn some of the basics of Make, understand, tabs, not spaces, understand .phony and what that is, because that can kind of trip you up. It's useful to understand the variable assignments, understanding that each command runs sort of in its own shell. These are things that you're going to hit if you don't learn it. And maybe, honestly, most of the time, all the people I've worked at learned it the hard way by saying, hey, this thing isn't working. Why isn't it working? Just know that kind of your first point of contact maybe should be to go check out the Three Musketeers website. They've kind of talked through some advanced Make things and patterns that have worked for them. I'd start there first because the problem you're facing probably has been experienced in this pattern. Having a clean Make file is ideal. You should really only try to use the basic features. If things start to get complex, maybe you should push that complexity down the stack into Compose or even into Docker. Make does some orchestration, but again, it can do a lot of things you're looking for. It's just hard to read. If you're taking advantage of that, do take advantage of comments and help and all of that, because it can really be hard for newbies to understand. I've touched on environment variables. We hit this a lot when we were kind of starting to implement it. So keep in mind, make is shell-like. It's not a shell. You can't set variables. You can't set environment variables inside to be used on future make calls. So generally, you'll see if you want later commands to take on some output or some environment variables, you'll generally do that through files, which is a little kludgy. Variables come from the environment. Every environment variable that makes Cs will be transformed into a make variable. You can explicitly override it. You can export. So when you're doing, if you've set environment variable, if you've set make variables from either the environment or the command line, those will get passed automatically through recursive make calls, like in that private sort of syntax. If you've set other environment variables, those aren't, but there is an export command. Again, this is probably getting a little deep in the weeds, but if you find you're having to recursively call different make commands and certain variables aren't getting passed through, you might need to export them. And try to take advantage of Docker and Compose's ability to leverage an env file. Again, typically that'll be some file that isn't committed into Git because it probably will have secrets or things that are specific to your local environment. And a lot of teams will, I'll create my own .env file locally so that I can kind of quickly and easily spin things up. Gotchas, things that I've kind of come across that have horked me a little bit. Leveraging Docker, really cool. By default, if you don't specify a label, it's going to use the latest. Like any other dependency, if you are always on the latest version, while it makes your maintenance a lot easier, it doesn't make things idempotent, and you'll find things that work one day don't work the next day, and you don't know why, and it's because something shifted underneath you. So generally not a great practice to always be on the latest version of everything, but also a good practice to kind of continually garden these dependencies and try to stay up to date. Make sure you clean up after yourself. Again, like I said, if you're on, especially on a shared build agent, this isn't cleaning up Docker images and containers isn't something that generally your CI/CD tools are going to do for you unless they're more modern ones. File permissions. This is the one that kind of works us up the most. So I pointed to volume mounts, and that's really nice because it kind of gives you the ability to be able to work locally and then sort of take advantage of all of that caching and whatnot. The problem is by default, Docker runs as root. Therefore, all the files and folders that created within that Docker image on the volume mounts are mounted as root. And then unless you have root access to your machine, you can't delete those. So make sure you clean up after yourself, but there's other ways that some are kind of hacky of kind of getting around that, where you can kind of create a non-root user that can kind of solve some of that. The problem on most Linux systems is they're ID based. So my user ID on my Mac might not be the same as your user ID on your Mac, might not be the same as the user ID that the build agent's running as on their Linux machine. So it can get really challenging. There's a couple links to kind of get around that. That's probably the biggest pain we've had so far. Secret management is still challenging, like it always has been. This doesn't really make that any better. The only advice I can give you is use the same solution across all of your environments, and it makes things a lot easier, having that consistency. Ensure you're up to date on Docker and Docker Compose. Like I said, older versions of Docker Compose didn't support that .env file passing in environment variables. So do kind of make sure you're on a more newer, modern version of that. Hopefully that's easy for you to do. There are ways I've been in environments where they have Docker and make, but not Docker Compose, or an older version of Docker Compose. And you can have generally have make either through a shell or through a make command, download a newer version of Docker Compose and install it locally. So that's one approach we've done. Really quick, I'll try to jam through this because I know kind of people are probably wanting to get going. Alternatives, right? You don't have to use make and compose and Docker. That you can pick two of them. If I generally start by using make and Docker, and when I need when complexity has happened, I'll add Docker compose. Sometimes I don't even need it. If I'm in an environment that doesn't have make, maybe I'll have a better alternative. You can pick and choose these things. The key is focus on consistency, control, and confidence. You want to give teams the ability to control within guardrails the versions and the tool chains that they want to do. You don't want to have them depend on another team. So get agreement within your team, within your organization, to use a standard that's easy. If you are a Java shop and you're only a Java shop, maybe it doesn't make sense to use make. Maybe everybody's using Gradle. Great, like do that. Use that, leverage that. Just try to make it consistent across teams, and you really start to scale. Yeah, I guess that's all I'll say on that. There is a thing called Two Musketeers, which is no joke. It's basically dude didn't like make or compose, and so he basically recreated a lot of that stuff using Bash. It's about 50 lines of Bash condensed, about 150 lines of Bash with sort of annotated. I find make easier to read. It's kind of a nice little DSL, but hey, cool, it's there. Use it if that's what you like, if you can't get make. A lot of teams will just use bootstrap scripts, like, hey, run, at least give you some consistency of what a development environment looks like. So it'll run Bash that calls Homebrew, or PowerShell that calls Chocolatey to install all of your dependencies. If that's where you're starting, cool. Use it, keep it up to date. It's one less thing. And again, there's real money involved in terms of getting that new person ready to build and push a commit, and that creates a build that potentially creates releasable software. The faster you can get there is really money saved. There's another one, Garden. I don't know anything about it, but I saw it, so I thought I'd build in there. All right, questions answered. Like I said, I'll shoot you out a bunch of links. There's some Kata Koda stuff, if you've ever used that we have some courses that you can even get your hands dirty without kind of getting all this set up and kind of play on your own. Yeah, I'll leave this time for what people think, or if they have questions. Hopefully people are still here even. Yeah, you have
a question for you.
Yeah, shoot.
First, I just want to say that's I really like what you did there, kind of having that standard environment and trying to abstract away all the complicated stuff in your CI system, or not trying to abstract it away, but make it accessible so you can run it locally. It's a big problem I've been working on trying to solve lately. I wanted to actually point out a tool that I've been looking at called Earthly. And so it uses the Go build, or like the multi-stage build type syntax, but you can use that to run. It basically runs all your steps in parallel, and it caches dependencies between the steps. It solves a lot of what that tool solves, but kind of standardizes in one tool instead of having the three. So I guess my question is how much time do you spend supporting other people trying to learn this pattern?
I spend a lot of time because I'm a consultant, and half of my job is to upskill and transform the people that I'm working with. And this is actually we kind of a victim of our own success. This was just a pattern that we wanted to kind of sort of throw out there, but not enforce on teams. Just say, hey, look, because what we're doing something kind of more on a verification governance standpoint. So we've kind of got our own pipeline of things, but it impacts these teams. And unfortunately, the senior management thought it was a fabulous idea and now used it as a stick and said, "Thou shalt use 3 Musketeers." And we're like, whoa, that's not what we're saying. Like, nope, thou shalt use. And so now everybody's like, oh God, now I've got to do this. So we're a bit bogged down in a little bit of training. I think the biggest thing, and everybody talks about training, I think the biggest thing is, for me at least, it's easier to show. So I try to take an example, their applications or one of their components, translate it in a little bit just to kind of get them started, so they just see the idea, and then they can usually go. If they really are interested, most of the time there's enough stuff that they can point and self-learn. I find the hands-on training of sitting next to people. We do a lot of pair programming, so that really helps. That's helped us with the teams we're working with. But for the application development teams we haven't been, there's a lot of fear, uncertainty, doubt. Oh, this doesn't work because I use Gradle or I'm a mono repo. That we've struggled a little bit to overcome because I don't think the message was delivered quite as well.
Yeah, it's impressive that you can train people on this. We're having a hard time just getting people to understand, Docker itself, let alone trying to, mix in those and make files.
Yeah, and there's a legacy world that doesn't do any. We're working with some greenfield teams that are more Docker centric, so it's a little bit easier. But there are a lot of engineers that we'll be working with that aren't exposed to Docker or Docker Compose, and so we do kind of have like a 101 and a 201 course, but nobody takes the prerequisites or anything like that.
Thank you.
Yeah.
All right. Any other questions?
I'll go check out that Earthly at some point. Thanks for that.
All right. Well, thanks a lot, Andy, for that great presentation. So I noticed you had a GitHub link. Is that what you'd be kind of sharing with the group and stuff?
Yeah, I'll create a PDF of this prezo that'll have the link, and I'll also send you the link to it as well.
Okay, awesome. We'll make
there's like all of these links in here, and the first one is the link to that GitHub repo.
Nice. Great. Yeah, we'll make sure to get that out there on the site so everybody that registered for this can get it. And then we'll also be taking the recording and putting it out on our YouTube channel. All right, so let's can you go ahead and make me the host again? It's like,
yeah. Close this. It'll cost you one of those gift cards. Just kidding.
Well, odds are pretty good right now. So
doesn't feel fair for the speaker to get a gift card.
All right, let me share screen. All right, minimize all these. All right, can you let me know when you can see the screen?
Yep.
All right, so we're going in, and here's my fancy tool. I did say last time I was going to make a bash script. I haven't quite done that yet. I did install the Windows subsystem for Linux v2, so maybe I don't think I really needed that, but to do this, here I got everybody's name in there, including you, Andy. Speaker here. Here's my fancy script. So we'll go ahead and draw this twice, and then we'll connect up those winners with Derek afterwards. So, whoops. First winner is Brandon. All right.
Hey.
And hopefully the second winner is not Brandon, but we'll see. All right, Andrew. So we came back and was a winner too. So again, thanks everybody for joining. Thank you, Tech Systems, Derek, for being our sponsors. We'll make sure to get you guys in contact with Derek to get your prizes there, and we'll see you next month. I think we're on the 8th or 9th. Can't remember, but I'll send out some information on it. But thanks again. Thanks, Andy, for doing a great presentation, and we'll see you next time.
Hey, Mike, can you send out a link to that global DevOps challenge thing you were talking about? I hadn't heard of it. I forgot to go.
Yeah, absolutely. Yeah, it's on the meetup too.
Oh, okay, cool. Perfect.
I'll send that out though. Yeah, great.
Cool.
Great point.
Well, thanks, guys. Hope you all have a good evening. Stay healthy. Stay safe.
Thanks. Great presentation, Andy.
Have a good one, guys.
Thanks.
Bye.
Bye.